So, you're stranded on a desert island. How can a little bit of basic science actually save your life? Today, we're going to tackle that classic survival scenario and explore the chemistry that can turn a totally hopeless situation into a puzzle you can actually solve. Okay, picture this. You've washed ashore on a desert island. You're hot, you're desperately thirsty, and all you can see from miles is the endless ocean. Water, water everywhere, but here's the kicker. Not a single drop is safe to drink.
And that's the core challenge, isn't it? The ocean water is a mix of salt water and sand, and drinking it would actually be more dangerous than drinking nothing at all. To survive, you have to figure out how to separate the pure, drinkable water from all that other stuff.
Okay, so let's dive into this. To solve this puzzle, we've got to get scientific first. You have to know your enemy, right? We need to understand exactly what we're dealing with.
That sandy, salty water is a textbook example of a mixture. The sand, salt, and water are all just hanging out together. They aren't chemically bonded. And that right there is a crucial distinction, because it means we can find ways to pull them apart again.
Now, if we zoom in a little bit, there's something more specific going on. The salt water itself is a special kind of mixture that we call a solution. And that's just what you get when one substance completely dissolves into another. In any solution, you've basically got two parts. First, there's the solute. That's the solid stuff that seems to just disappear into the liquid. In this case, that's the salt.
And the liquid that's doing all the heavy lifting, the dissolving, that's called the solvent. So on our island, the water itself is the solvent. So to put it all together, we've got a salt solute dissolved in a water solvent. Simple as that. All right, enough with the theory. Let's get to the practical stuff. First step is to tackle the most obvious problem, all of that gritty sand.
Now here's some good news. Unlike the salt, the sand doesn't actually dissolve in the water. It's what scientists would call an insoluble solid. And because it hasn't dissolved, we can get it out with a pretty straightforward technique: filtration.
Filtration is super simple. It just means passing the whole mixture through some kind of physical barrier. Think of it like your coffee maker at home. The filter paper lets the liquid coffee through, but traps all the solid grounds. The filter has tiny holes that are big enough for water molecules to squeeze through, but way too small for the sand particles. The sand gets caught, and the liquid flows free.
So, we've cleared one hurdle. That's a huge win. The water isn't sandy anymore. But, and this is a really big but, we're not safe yet. It's still dangerously salty.
Okay, now for the main event. This is the real challenge, the part that's actually going to save your life, separating that dissolved salt from the water.
See, the salt is dissolved down to the molecular level, so our simple filtration trick won't work this time. So how can we possibly get it out while also keeping the precious water?
Well, we could just boil the salt water, right? As the water heats up, it'll turn into steam, a gas, and just float away. This whole process is called evaporation, and it would leave all the solid salt crystals behind.
But wait a minute. If the water turns into steam and just disappears into thin air, we've gotten rid of the salt, sure, but we've also lost the very thing we need to drink. We've solved one problem, but, created a much, much bigger one.
And this little problem leads us straight to the complete, brilliant solution, a process called distillation. It starts with evaporation, but it adds one more crucial life-saving step.
Distillation is this really clever two-step process. First, you evaporate the salt water, turning the pure water into steam and leaving all that salt behind. But then, and this is the key, you capture that steam and you cool it down. As that steam cools, it condenses, turning right back into pure, liquid, perfectly drinkable water. So there you have it. We've survived the island using science. But this isn't just about some crazy extreme situation. This kind of science is all around us, every single day.
Think about it. Making your coffee in the morning. That's just filtration, separating the solid grounds from the liquid. If you've ever boiled a pot of water on the stove until it's totally dry, you've just performed evaporation. And on a massive scale, huge desalination plants use the exact principle of distillation to provide fresh drinking water to millions of people.
So really, the key takeaway here is that our world is just built on mixtures. And once you realize that, it gives you a powerful tool, the ability to separate things. Whether that's to survive on a desert island or, just to make a great cup of coffee.
And that leaves us with a final thought to chew on. If we can pull life-saving drinking water from the ocean with just a little bit of science,
What other essential resources are locked away in all the everyday mixtures around us, just waiting for the right process to set them free?